Hi everyone, this is Mrs. Ruscio, and you are watching Piecewise and Step Functions Day 1 Notes video. In this video, we're going to learn about these two different types of functions, and we're going to be able to interpret them and graph them. So in order to understand what these graphs are, it's a good way, or the best way to kind of do that is by looking at a picture of them. So example number 1 shows us what a step function looks like. And down below here, you're going to see, and there was a couple little highlights that were missing. So if you have a yellow highlighter, you should highlight both of those yellow because they're important. We're going to talk about that in just a minute. You can see this entire function. It looks weird, right? It's like, what in the world is all of this? So being able to understand what they give us versus what we should graph is a skill. So this piece here, what this really means, what does this really mean? Well, it means graph y equals 6, right? Isn't f of x the same thing as y? I'm just going to write that down so we don't forget it. Graph y is equal to 6 between when x is equal to 9 and x is equal to negative 5. That's this little interval part of the step function over here. Okay, graph y equals 2 between x equals negative 5 and x equals negative 4. We're going to talk about those highlights just a minute. And then the third piece is graph y is equal to negative 4 only where x is negative 4 and 9. So there are some transition points, right? Negative 9 is a transition place, and this is an x value, right? Because this is our domains. These are all the x values. Negative 5 is another transition place. Negative 4 is, and so is 9. And as you can see, there's points that start and end at every single one of those x values. You just have to look above or below. So some of you might look at the graph and wonder, looks to me that there's some open points and closed points. Well, we've talked about this before, right? When there's an open point, that's a less than symbol. When there is a closed point, it's a less than or equal to. So check it out. At negative 9 and negative 5 for the first piece, they're both open. At negative 5, it's closed and then open for the second piece. And then for the third piece, negative 4 to 9, negative 4 to 9, they're both open. Okay, so that's where all of that is coming from. Now we can interpret this graph. So let's take a closer look. F of negative 7, when x is negative 7, let's look at our y value. Our y value is 6. When x is negative 5, our y value, if I look below, isn't anything. Up above, ooh, that looks like it's 2, but wait a minute, is it also 6? No, because it's an open point. Open point means that it's not actually there. It gets really, really close to it, but it's not actually there. And then when x is 2.3, that's somewhere here. So if we look down below, that is at negative 6. Okay, now if we graph this on a calculator, we're going to see something like this. Okay, and some of you might wonder, like, how in the world did you get that to appear? Well, have no fear, look no further. Example number 2 is a piecewise function similar to a step function. Like steps looks like steps. Piecewise functions are going to look like pieces of functions. All right, so now is the time to grab your calculator. Control, doc, add a graph. You're going to press the key of everything next to the 9, and this little button here is going to give us all of the joys of a piecewise and step function. You can use it for both. We have 1, 2, 3 pieces, so we're going to keep that 3. And then it creates this template for us. Oh, yay, happy day. So we have 2x plus 3. We also have x squared minus 4. Be careful you're using the minus sign. And then this is negative 7. So make sure that you're using the negative sign. In all of these pieces, we're going to, oops, I don't mean to do that. Oh no, I just ruined everything. Okay, we got to do this again. Sorry, I lost everything. Let me just do this quick again. All right, so 2x plus 3, and then x squared minus 4, and then negative 7. And then in order, this is what I was trying to do, we have to fill in these pieces here. So negative 6, control equals is less than or equal to x, control equals is less than -3. So that's where you'll get your inequality symbols. So -3, control equals, less than or equal to x. You should really follow along if you can on your own calculator because we learn by doing and not just by watching. And our last piece, this one looks a little different, but this just means x is bigger than or equal to 2. And then once you hit enter, we get these 3 pieces. Well, some of you are like, wait a minute, shouldn't we have gotten 3? Yeah, we should have. So let's change around our window. Look at y has to equal -7. We're not even going to -7. So I'm going to go all the way down to -10 and hope that another part appears. And voila, it does. All right. Control, actually, no. Let's just go to the menu. Okay. Menu, analyze graph. Actually, let's trace it. I think this is a better option. So let's trace the graph. Remember to change your trace step to 1. And then menu, trace this graph, graph trace. And we can move to the left and right using arrows. Now, this is the cool part about this. See how we're at -7? It doesn't begin. But as soon as we get to -6, ooh la la, there's a point, -6, -9. Now, each one of these 3 pieces, remember again what this means. We're going to graph a line, y equals 2x plus 3, between x equals -6 and x equals -3. Graph f of x is equal to x squared minus 4 between -3 and 2. And then we'll graph f of x, or y, is equal to 7 between 2 and infinity. Why infinity? Well, it says x is bigger than or equal to 2 forever and ever and ever. We're never going to end. Okay, so let's start plotting these points. I'm graphing my first function, well, this is all the same function. I'm graphing my first piece at -6, -9. This, my friends, is a closed point. Why? Because it's a less than or equal to symbol. Okay, using our calculator, -5, -7 is my next point. Okay, that's not an end point yet, so we don't have to worry too much, but when we get to -3, we do. Our next couple points, -4, -5. And then, well, that was weird. Okay, so -4, -5. And then let's keep following the same pattern. But at -3, we have to have, you guessed it, an open point. So did you guys see what happened on the calculator when I went to the right? It jumped and skipped over that point because it's not really there, but it is. So that's why we have an open point there. Okay, then let's use these points. Okay, well, this is nice. -3, 5. So -3, 5 is my next point. And that's closed because it's a less than or equal to next to that -3. I'm going to go to the right at -2, 0. We're going to keep following this pattern. -1, -3. Keep going, 0, -4. Oops, I plotted this one wrong. -1, -3. Sorry, that was off a little bit. Good catch if you got that. 0, -4, 1, -3. And then, ooh, this is interesting that it's actually selecting this. And it looks weird, right? 2, -5 point, blah, blah, blah. But we know better. That's supposed to be this point here, but it's an open point because look at x is less than 2. So at that point, it has to be open. All right, keep going to the right. Now, that's doing something weird, so we have to be careful. X is greater than 2. We're going to go all the way down to -7, and that, my friends, is a closed point forever and ever and ever and ever and ever. Okay, so I'm going to also connect this with a curve to make it look that way. This is my function f of x. But as you can see, the calculator can help us, but we also have to have some knowledge of open and closed points in order to be able to graph it correctly. Okay, another thing that you can do is menu, view, grid, line grid. And this can also help us find those points. Okay, some of you might take advantage of this. All right, last, let's finish this off. I know this video is getting kind of long. Find x equals 1, find the y value, so find f of 1. So if we go where f of x, when x is 1, we're going to look down and see when x is 1, y is negative 3. Verify on your graph. That's correct. Now this says algebraically, so what could this mean? Well, we have to show some algebra. So look at our function up above. When x is 1, where does that fall in my pieces? Is 1 bigger than or equal to 2? No. Is 1 between negative 3 and 2? Yes. So we're going to take this piece, x squared minus 4. Notice how I ignore all the others because it doesn't matter. We sub in 1 squared minus 4. 1 minus 4 is negative 3. And we verified it on the graph already. So we are happy.